Before knowing about multi-threading, we'll first know about a thread. What is a thread? In computer science, a thread of execution is the smallest sequence of programmed instructions that can be managed independently by a scheduler, which is typically a part of the operating system. So what is multi-threading? In computer architecture, multi-threading is the ability of a central processing unit, that is CPU, or a single core in a multi-core processor to execute multiple processes or threads concurrently, appropriately supported by the operating system. So why do we use multi-threading? We use multi-threading than multiprocessing because threads share a common memory area. They don't allocate separate memory area, so saves memory. And context switching between the threads takes less time than processes. Java multithreading is mostly used in games, animations, etc. In a single threaded application, one thread of execution must do everything. If an application has several tasks to perform, those tasks will be performed when the thread can get to them. A single task which requires a lot of processing can make the entire application appear to be sluggish or unresponsive. In a multi-threaded application, each task can be performed by a separate thread. If one thread is executing a long process, it does not make the entire application wait for it to finish. So, this is why threads are helpful in order to complete a particular task. If multi-threaded application is being executed on a system that has multi-processes, the OS may execute separate threads simultaneously on separate processes. So, it saves time. If a multi-threaded application has to perform a task, then that task is divided into n number of subtasks. Each task is assigned to a thread. The thread executes the task. All the threads share a common memory area, hence the memory wastage is prevented. The execution of threads is also faster, hence the task is also completed in a faster rate. In Java, threads are represented by a thread class. A thread object maintains the state of thread. It provides control methods such as interrupt, start, sleep, yield, wait. When an application executes, the main method is executed by the single thread. If the application requires more threads, the application must create them. A thread state. A thread can be in one of the following states. So let us see what are those. New. A thread that has not yet started comes into a new state. Runnable. A thread executing in a Java virtual machine comes into the runnable state. Blocked. A thread that is blocked waiting for a monitor lock comes into the blocked state. Waiting. A thread that is waiting indefinitely for another thread to perform a particular action comes into the waiting state. Timed waiting. A thread that is waiting for another thread to perform an action for up to a specified waiting time comes into the timed waiting state. Terminated or dead. A thread that has exited comes into the dead state or terminated state.